Hi, in this video I want to show you how to translate between position and velocity graphs. If you know what one graph looks like, can you make the other graph? So let's start with a position versus time graph, and let's try to make the velocity versus time graph that goes with it. So I have added in these dotted lines here to show that these two graphs are parallel with each other. They are lined up together, so that 10 seconds in the position versus time graph is lined up with 10 seconds in the velocity time graph. So that's what these vertical lines are here for. I chose to put them here because it's helpful to break up the position into these three sections so we can analyze what's happening in each little section. So starting off here, what is the object doing in this first section? This is a position versus time graph, so it's staying at the same position, which means it's moving at zero velocity. So for this first section, the velocity is 0. Then we have the object move in the positive direction at a constant speed. The slope is staying the same throughout, and so it's moving at a constant speed in the positive direction. So how would I show that on a velocity time graph? Well, if it's moving in the positive direction, I know I'm going to need to put it in this section and not down here. So positive velocity. And its slope up here is staying the same. It's not sloping upwards or downwards. I mean to say it's not getting gradually steeper or, and so that means that the velocity is going to be a constant value here. And so we're going to show that like a constant positive line. You'll notice that I left a gap here, and that's because we're being a little idealistic about this. We're saying that immediately the object went from rest to moving at a constant velocity. So we would show that by basically just drawing a straight line up to this moment. In reality, there's always going to be a little bit of a delay. There's going to be some time there. And I've actually kind of drawn it like that in this picture here, that there's a quick jump up to a positive velocity. Then we end the position graph here with a 0 slope. So it's at rest again. So the velocity is dropped back down pretty immediately down to rest. And so this is the correct translation from position to velocity. Let's look at another example. All right, in this one, we're going to go from a velocity graph and translate that into a position graph. Now we have a little bit more freedom in this one because we're not told where the starting position is. And so we can basically choose it, and we want to choose it so that it fits, it makes it fit correctly. I don't think it's going to be a problem in this example, but we can choose where to start our position. We start off with 0 velocity, and so whatever position we choose, we're going to stay at that position for this first section. So I'm going to start, this is my starting position right here, and we could choose anywhere, but that's where I've chosen. And that 0 velocity is going to look like a straight line in that section, relatively straight. Then we have a constant positive velocity for this region of the graph. So we're going to go constant positive velocity. And then suddenly the object moves with a constant negative velocity. And so that'll look something like this in the third section. And then the fourth section, we're back to rest. Now, the graph that I've drawn here, it can be moved up and down freely because I chose my starting position here. I could have chose my starting position up here and drawn the same graph and it would still be correct because it doesn't tell us in the velocity time graph where our starting position is. And so we can choose it if we are not told. All right, let's do one more example. And we're going to do another example where we have the velocity time graph and we're going to try to make the position time graph. So in this case, we start off with basically 0 velocity, start off very slow, and then we begin moving in the positive direction and our velocity is increasing steadily. So it's getting faster and faster and faster. So what would that look like? Well, again, we can choose wherever we want to start, but in this case, I want to have enough room so that I can move in the positive direction. So I'm going to just start down here so I have enough room to draw this. And I'm going to start drawing it with a very, very low speed, like almost zero speed at the beginning, just a tiny little bit of velocity, and then the velocity is getting faster and faster and faster as it gets away from the zero. So I'm going to go faster and faster and faster until I eventually reach this moment where the velocity doesn't stop, but it stops speeding up. And so we will continue to move at this speed that we ended at, but we're going to continue to move at that speed for this whole section. So that's going to look like this. It's going to be a straight line. Right, so I've got started out going slow and then faster and faster and faster, and then we stuck to that constant speed for this moment. And then once we hit this third part of the graph is when we actually stop. And so the motion actually stops here. So that's what this graph would look like. Well, that's all I've got for you in this video. Remember, everything you have is a gift.